Hey, this is Don from Padlock Technologies again with another video. We are finally finalizing or rounding everything up together, and we are at the end of MPLS Inter-AS L3 VPNs, and we are going to end this on option D. Now, I did A, I did B, I did C. If you want to see what C looks like, there is going to be a video in the card over this way. I keep going the opposite way over here, or probably above my face. That's going to send you to the video for option C. Now, you could stop this video here and go learn about option C, but since this is option D and it combines option A and B, it is probably better for you to learn option A, which, here's a card above my head for option A. And then in option C, there's going to be a video to go back to option B. So you need to know what option A and B is to kind of learn what option D is. Now, option D is not actually taught a lot. Very few people know about option D. I've talked to some CCIs and service providers. They didn't even know option D actually exists. Not saying everybody doesn't know it exists, but it's a very new style of doing inter-AS L3 VPNs that few people know and few people actually teach, right? So what is option D? And I just said what it was actually. It is option A and option B combined together. Now, it's option A from the data plane standpoint, and it's option B from the control plane standpoint. And what we're talking about here is really at the ABRs, right? Everything else is fairly the same from an MPLS standpoint, from a BGP standpoint, from an underlay standpoint, but the ASBRs are going to act a little differently, right? So as you can see over in this area here, you see hybrid, inter-AS hybrid. So what we're doing is I have three sub interfaces and one main interface. The main interface is going to have the VPN v4 peering and the command enter AS hybrid. So what does that do? Well, what you're going to see at the ABRs is from a control plane perspective, the next hop is going to be the global address from the control plane perspective. So when we do show BGP VPN v4 unicast all, you're going to see the next hop be the global address of the next ABR. But from a data plane standpoint, we are going to override what the control plane says, and then we're going to say, hey, that next hop is actually in my VRF, and it's going to point to the other VRF side, right? So it's really overriding the BGP control plane next hop with the data plane next hop for the VRF, right? So the VRFs will exist on the ABRs. This is not like option B that doesn't have the VRFs on the ABRs, or option C that doesn't have the VRFs on the ABR. So control plane is option B. Data plane for traffic separation is going to be option A. So all the routing tables will be separate. I'm pretty sure not a lot of people actually seen this technique, and this might end up being an interview question for some people out there that's actually watching this video, and just to see if people actually know things about BGP or anything about service provider networking. You can ask them what are the four options for inter-AS L3 VPNs. Most people will say the first three, A, B, and C, and they're probably going to get stumped on D. But if you watch this video, now you know it's option D. So I'm not going to bore you with all the underlay stuff that we already seen in option A, B, and C, right? All MPLS is set up. The CEs are set up correctly. What we're going to do now is focus on the ASBRs, because this is where option B is actually going to take place. So let's go ahead and open up ASBR, our router 4, which is our ASBRs. And what we really want to take a look at here is from a VRF perspective. Just like I said, all the VRFs are here. As you can see, the VRFs are here. Now I want you to pay attention to a certain command right here. Enter AS hybrid next hop, whatever the next hop is. And this is technically ASBR5 sub interface for customer A. Now, what this is actually doing is it's going to override the control plane next hop with this IP address and not the IP address of the BGP control plane. So technically the BGP control plane next hop is going to be 172.18.1.0. But if it's for a route that is in customer A's VRF table, it is going to overwrite that with 2.0, which is router 5 or ASBR 5, but in VRF-A. So you see that I did that in every VRF, right? So this is kind of the first step here, right, to do the AS override. The next thing you have to do is you have to actually go into the BGP configurations. And I did this with a template because you know I like using templates. So for eBGP template, we have our peer session, which is our basic peer session. You see me do that probably like 6-7 million times by now. So you just know what a peer template is, and this is only for iOS. IOSR uses a neighbor group, so you have to know that. And Nexus OS uses templates as well. But for eBGP, we got the eBGP peer session template, which is just going to say, hey, it's the remote AS, and then obviously my source update. And then the peer policy, this is what activates along with the VRF command that I just showed you, inter AS hybrid, which is option D. So you need to do that. Once you do that, what you're basically telling them is, hey, the control plane is going to be formed over the global address, but the next hop is going to be overwritten by what's in the VRF. Okay. And then the next thing you do with option B, obviously, because we're using option B control plane, just like we did with option B, we have to do the next hop self command so that when we send it to the route reflectors, we actually have a next hop that we can get to, which is the ASPR. Once you do this, you have now activated option D for MPLS inter AS L3VPNs. But what does that look like from a control plane and data plane perspective? So the first thing we're going to do is we're just going to look at the VPN v4 table. So you can see that the control plane is going to show that the next hop is the global IP address on the router 5. So if we look at show run interface G1, which is the global, you can see here that it's router 4 is .1, router 5 is .0. When you do the VPN v4 neighborship like we did last time, which is option B, as this is MPLS BGP forwarding, but we're not really going to be sending anything on the global table, right? So if I do 1.2 here, is it 1.1 or 1.2? Yeah, I think it's 1.2. That's it, yeah. So 1.2 is going to be customer A, and this is why when I showed you that inter AS hybrid next hop 172.18 2.0, this is the customer A, which is 2.1. So I just want to do customer A for now. Now, from a data plane perspective, you will get the same trace route as option A. So when it goes to router 5 or go to router 4, it will turn into an IP packet. So it will be an IP packet, and then when it gets to the other end, a new label stack will get put on with a transport label and a service label, and it'll be sent on its way to its respective PE. So you still get the IP packet for option A, right? You still get that, PHP process, VPN label gets popped, IP packet gets to the other side, VPN label and transport label is pushed on, which is the imposition, and then you have the switching and the PHP process on the other side, pops it off, VPN label or service label, whatever you want to call it, and then that turns into an IP packet when it gets to the other end. Now, let's look at the BGP VPN v4 table so you can see the next hop, right? So show BGP, VPN v4, unicast, all. So as you can see, let's go with customer A. So as you can see, here's a route for customer A. So if I'm on 4 and this is 16, so I got 13 that's pointing to router 1 that's in my service provider network. And then I have 16, which is down here, which is in AS2 as 65002. But as you can see, the next hop is 172.18.1.0, which is the global address on the other side, which is router 5. But now we're going to go into the actual routing table of customer A on the ASBR4, and you're going to see the override happen. So the override is customer A, it should be 2.0. So if we go show IP route, Come on. VRF cus A. There you go. So to get to 16, it's going to 172.18.2.0. Completely different than what it says right here, which is 1.0. So the enter AS allows you to override the next hop from option B to make it look like option A, right? So what is the benefit of this? Well, you don't technically have to do a peering at each and every VRF, whether it's going to be BGP or OSPF or any of that. You don't technically have to do that. You just do the AS override or enter AS hybrid override, tell it what the next hop is, and then that will take care of itself. So that's the beauty of it, right? So you get the singular control plane of option B, and you get the traffic separation of option A. What is the downside? You get the traffic separation of option A. So the more customers you put in your environment, the more configuration you got to do from a VRF standpoint with the inter AS option. And that's really all you got to do at the VRF level, because you're just going to establish that one VPN before peering at the global level. But every time you add a VRF or every time you add a customer, you have to do the inter AS hybrid next hop command in every VRF you have. So you get the same limitation of option A, or the same cons of option A, which is if you have thousands of customers, you can see how you can have thousands of sub interfaces. Let's just say hundreds, not thousands. Thousands is kind of crazy. But let's say you have hundreds of uh, separate sub interfaces that you have to do this command to. But it's pretty cool because, again, you could have the single adjacency, option B, but you have the traffic separation, option A. You do not have encryption though. So you would, if you would do this with Get VPN, you would really be in some trouble because let's say you had 100 of these things and you're doing Get VPN. Well, now you have to do these configurations on multiple ends and all that good stuff. So you got to be careful trying to use encryption, but you still have the same traffic separation. So VRF table A doesn't see B or C unless you do some kind of route leaking with the importing and exporting route targets. So now you see for yourself where the BGP control plane next hop is the global address, but in the actual routing table itself, it changes the next hop to the actual next hop that it can get to, which is whatever you configure in the next hop command for inter AS hybrid. Now, from a control plane perspective, let's see what that looks like. So I'm going to do the BGP one. I do have EIGRP and OSPF. All this is configured already and reachability is there. So I'm not going to waste your time doing EIGRP or OSPF. I'll just go down to BGP because in the real world, you're not really going to get to do EIGRP or OSPF to the service provider. They really don't want you doing that because they like using BGP because BGP is more policy based. Think about BGP is just it's a path vector protocol, but it's more policy based, so you have more control compared to OSPF and EIGRP, right? So in the real world, your service provider is probably never going to allow you to do OSPF or EIGRP for a peering VPN. Now, overlay VPN, which is a layer two VPN, so Ethernet, emulated Ethernet, stuff like that, they don't really give a crap because you're not peering directly to the service provider. You're peering through the service provider. That's why they call it an overlay VPN compared to a peering VPN where you're peering directly to the service provider. So if you're doing like a L3VPN, they don't care because you're going to do the routing protocol through an emulated like Ethernet, which is either going to be EVPN, L2VPN, or L2VPN, EVPN, VPLS, or VPWS. So we go through here, and first we got to look at the routes to make sure we actually got that route there. So that's 16, which is down here. So I'm at 13, which is right here. And then I'm going to 16 to loop back on 16, which is down here. So let's first make sure we can actually ping it. I'm on 13, so I should need to go to 16, source. So we got pings. We know that works. So now when we trace route, and you'll see it in the trace route, remember, the next hop was 172.18 1.0 from the control plane. But you're going to see in the trace route where it switches to 2.0 from a data plane standpoint. Hopefully I spelled trace route right there. 16 source from the loopback. And let's just watch it. So we should go to the PE, which is router 1. Taking forever, so that's router 1. And then we should go to router 2, I believe. Yep, router 2. So we should have a transport and service label, which is transport is 202. VPN service label is 407. So then we get the 407 after the PHP process happens. So we're now at router 4, and this is where you just saw the switch right now. Come on. There you go. So now that's an IP packet. But we'll wait for the rest of this trace route. And now you're going to get the imposition happening with a push. So it's going to be a transport label and a VPN label, which is transport label 601, VPN label 705. And that's going to get popped off. And then you're going to have 705. So that was the PHP happening. Then the VPN label or service label gets popped off, and it's an IP packet. And then trace route should stop. All right. So as you can see, it got to 718.2.1, which was router 4, and it had that label, right? And if you remember from a control plane perspective, it was saying that the next hop was 172.18.1.0. But because we're doing inter-AS hybrid, it changed the next hop from a data plane perspective. It didn't care about the control plane. It cared about what it says from a data plane perspective. And it changed it behind the scenes to 172.18.2.0, which is a route that customer A on VRF4 or on router 4 VRF cus A can actually get to 172.18.2.0, right? So it changed it behind the scenes. And then when it got to router 5, it put the label back on and went on its merry way, right? But the real key here is inter-AS hybrid changes whatever the control plane says from, the global routing address to the data plane that you configure. And that is option D in a nutshell. So option D, when anybody asks you about MPLS or inter-AS L3VPN option D, just remember it is a combination of option A and option B. Option A from a traffic separation standpoint, option B from a control plane standpoint. And what you're basically doing is overriding the next hop in option B. Right, you're overriding that next hop that you see coming in from the VPN before adjacency from the ASPR standpoint, from the global next hop to whatever next hop you configure in the VRF. Once you do that, you will still see the next hop in the normal BGP VPN before table as the global address. But from the routing table, from the actual data plane perspective, when you do show IP route, VRF, whatever the VRF name, you will see the actual true next hop, which is what you configured. This is Don from Padlock Technologies. I really hoped you enjoyed this video. Remember, option D is not a inter-AS L3 VPN that's actually taught a lot. Not a lot of people know it. It's really fun to configure, and it's sometimes to get fun stumping people on option D. But if you watch this video, you've now gained some knowledge on a new inter-AS L3 VPN technique that you probably didn't know before. So I hope this video was informative. If you have any questions about some other technology, there's going to be a video bumper at the end that has the email address where you can send your questions. I always say this all the time. I don't know everything, but I know a lot. So if I can answer it, I will make a video just like the one you're watching now. And I'll tell you, hey, I'm going to make a video response. So be on the lookout. It's Don again. Thank you and have a nice day.